Hello everyone and welcome to another photon tutoring video. Today we are diving into the fascinating world of work, energy and power, but specifically we are focusing on mechanical energy and the way that it relates to conservative and non-conservative forces. Let's begin with conservative forces. Now, conservative forces are mainly your field forces, such as your Coulomb force, that acts in an electric field, your magnetic force that acts in a magnetic field, and your gravitational force that acts in a gravitational field. Note that because all of these forces act within a field, the work done by them only depends on the initial and final positions of an object and is independent of the path taken. We will be focusing mainly on the gravitational field in our study of mechanics. It's important to note that conservative forces conserve mechanical energy. Let's look at exactly how this works. This should remind you of K10. If we have a hill and a ball at the top of the hill, let's evaluate the potential and kinetic energy in the absence of friction. At the top of the hill, we have potential energy because the ball is away from the ground and therefore its height is non-zero, and so it has a potential energy value. If the ball is at rest, its kinetic energy is going to be zero. And so therefore we have the potential energy of the ball plus the kinetic energy, which is zero, equal to the mechanical energy, because mechanical energy is the sum of potential and kinetic. If we consider this to be our difference in height, therefore the bottom of the hill will represent a place where there is no potential energy. However, all of this potential energy would have been converted into kinetic energy. This makes the equation 0 plus Ek is equal to E mech. Now, in this situation, you'll observe that the only force acting on the ball was the gravitational force, which is a conservative force. And then all the potential energy at the top was converted to kinetic energy at the bottom. This means that mechanical energy remained the same. And whenever we have mechanical energy remaining the same, we can make this equal to mechanical energy at the top is equal to the mechanical energy at the bottom. And so we can say that the mechanical energy at two different points is equal. And if mechanical energy at two different points are equal, it means that the change in E mech is zero. And that is how mechanical energy is conserved when you have conservative forces acting on a system. So in this way, when you have conservative forces acting, the mechanical energy is equal to zero. In other words, the change in Ek plus the change in Ep is equal to zero. Now let's evaluate the effect of non-conservative forces, such as air resistance, frictional forces, and applied forces. Applied forces could be the force of an engine or a rope or anything that is causing the object to move because of a force that is in contact with it, or a force that is acting on the object. Now, these forces also do work on the object, but the work done by these forces, by non-conservative forces, cause a change in the mechanical energy. For example, if you have a block sliding down a hill, it is a rough surface, right? There is going to be a frictional force acting on the block. Some of this friction will convert the energy of the box into heat. And that's why if you have friction acting on something, you often get some heat there. Similar to when you rub your hands together, you'll feel some heat. That is a result of friction changing the energy or the type of energy from kinetic energy to heat energy. So the work done by non-conservative forces causes mechanical energy not to be conserved. Some of it is lost as heat. And so the kinetic energy at the top is not equal, kinetic energy at point 1 is not equal to the kinetic energy at point 2. And therefore you have a change in kinetic energy. And therefore mechanical energy is not the same, which means that delta E mech, when you have non-conservative forces acting, is not equal to zero. It's not conserved. So if the change in mechanical energy is not equal to zero, what is it equal to? To answer that question, we have to answer a more fundamental question. What is work in the first place? Work is when energy is converted from one form to another. What causes energy to be converted from one form to another? A force. So when you have a force acting on an object and you have energy that's converted from one form to another because of the force, you have work being done. Energy conversions are, for example, potential energy converted to kinetic energy or kinetic energy converted to heat energy. So let's get back to this question. If the change in mechanical energy is not equal to zero, what is it equal to? Based on our previous conversation, we can conclude that the change in mechanical energy will be caused by the work done by non-conservative forces. And that's how we get that second equation for non-conservative forces. That WNC is not only equal to FNC delta X cos theta. Now we understand that the work done by non-conservative forces is also equal to delta E mech, which means that it is equal to the change in kinetic energy plus the change in potential energy.